Hi everyone, in this video we're going to talk about percent agreement, inter-rater reliability, and interclass correlation. But first you have to understand the context of this project. So we are trying to code what we're calling items, which are responses on an online survey. And what is this response representing based on a coding framework of 6 codes? And then there were some extra codes like this is a nonsense answer, kind of things like that. So we have a master coder that is saying this is the correct answer. And then we have a group of coders that are coding 40, I believe it's 40 excerpts, 45 excerpts in this data set. So we first start by organizing the data like this. This worked for me based on the way that it came out of a Qualtrics setting. We have item 1, so excerpt 1, response 1. Everybody agreed that that was code number 1. And the correct answer, the master coder also agreed that it was code 1. So the percent agreement to correct was 100%, and the percent agreement across rater was also 100%. Here we can see that the correct answer was a 2 and nobody coded a 2. But we are getting 2 people saying 1 and 2 people saying 6. So this is actually flipped. That should be 0 and this would be 40. So we have 0% agreement with the correct answer, but we have 40% agreement, meaning 2 out of 4 are agreeing. We see similar patterns here. We have, let's go to item 18. So here, nobody agreed with the correct answer, the master coder, but everybody agreed that it was a 1. So our raters are agreeing with each other, but they're not agreeing with the standard. And so we're seeing discrepancies between those. So I went item by item, and then you get to the end, and we can actually calculate averages. So how much on average were we correct? How much on average were the raters agreeing with each other? And how many items were we getting correct out of the total? So about 50% of the time. So then what we did is we wanted to calculate, are the raters consistently answering the same way? So do we have one rater that's consistently off? And so when we see these 60s and 80s, is it the same person or is it random that people just kind of choose the wrong answer throughout? And we wanted to check that by rater, and then you'll see we're going to check that by code as well. So of the 6 major codes that we're trying to understand if these excerpts are representing, do we see differences by code as well? So here's what I mean when I say you have to restructure the data to what SPSS wants. So it wants the excerpt or the person being rated or the observation being rated or whatever it is that you are looking at. In this case, it was what we're calling items. So each excerpt, each response. And then we have the 5 coders. And we're saying, did they get it correct, yes or no? So in this case, everybody agreed and they were correct based on this. So everybody chose code 1. That was agreement with the standard. If we don't have a standard, that's when we would have to set what the agreement is for every case. So for example, if I was coding this item 6 right here, I would say 4 is correct because most people chose 4, and this person was incorrect. They were off of the main raters. In this case, I would say 1 is correct, and 3, this person would be incorrect because they were off of the raters. Regardless of whatever your standard is. If you don't have the standard, that's how we would look at it. Are we agreeing with the whole or are we off agreement? And so we see that item 18 here, based on the standard, it was a 0 across the board. Nobody coded that one correctly. So then I'm able to actually go through and write about all of the different ways that I did in a rater reliability. So we started with percent agreement by correct answer. So the raters agreeing with the master coder. And for this, it was only 40% as a whole. But they're agreeing with each other almost 60%, which made us question the correct answer. And do we need to change what is correct? Or do we need to train the raters better to understand what correct means? We also looked at the items and how many items matched the correct answer, and we're seeing about 50% agreement with correct answer. So there are some items that seem to be easier to code, some responses that are easier to code than other responses. And then I wanted to look at each code separately because we're seeing some discrepancies by code. Some of them aren't too far off, based on the rater's agreement versus the agreement with the correct answer. But let's just look deeper at code 2 really quickly. So we can see that we're only getting about 45% correct out of 11 items or responses. But the raters are agreeing on code 2. They're just not agreeing with what the master coder is saying code 2 means. So a major conversation needs to happen between the PI or the master coder and what is considered correct versus what the raters are interpreting that code 2 is meaning. Because the interpretation of code 2 we can see is off. Something's happening. Then we're going to get into ICC. So when we talk about ICC, we're going to be looking at the average measure column. This is the reliability of the different raters averaged together. And so we see the same thing. So this is just, do the raters agree with each other? Correct answer. Correct answer is not there. So if the raters are agreeing, that is now the correct answer. And any rater who's not agreeing with the whole is considered the incorrect. And we're seeing a 0.85 correlation, so a strong correlation, that the raters are agreeing with each other consistently for code 2. We see really, really major problems for code 3 here, that we have raters that are not answering consistently on code 3. Even though 50% of the time we're getting 3 out of 5 agreeing, who those 3 out of 5 are seem to be more random. Process that for a second. Then we go back and we calculate it again, and now we're looking at, are the raters agreeing with the correct answer? So looking back at code 2, we're seeing that a correlation of 0.57 is not an ideal correlation. That's only moderate. We would want a 0.7 or above to be a strong relationship. We interpret them the same way here. So for code 2, we're seeing that overall the raters are not agreeing with the correct answer. So again, we need to understand what code 2 is, how they're interpreting it, and get everybody on the same page. Interesting though, when we look at code 3 by correct answer, we're getting consistency with correct answer across raters. So raters are more consistently agreeing with the right answer. They're not necessarily agreeing across the board on what code 3 is. So that's what ICC is able to give you that takes it a little bit further than what we get by percent agreement. Still, holistically, we're seeing those patterns the same with percent agreement. What ICC starts to offer is how much of the agreement is random and how much of the variance in agreement is kind of looking at that true score for the whole data set, and then we can break it by each code.